Hi everyone. So good morning to all, and we are back into our session, right? So this is lecture number 33, and we are talking about Fourier series, right? So these, Fourier series, Fourier transform, they will be very useful in your communication engineering, communication system, as we will start, right? So at this moment, I just want to cover these topics so that you should be very comfortable. So I have done already a couple of lectures on Fourier series. So now the content that you have learned right in my class from the Fourier series is you have to, whenever the question is given, you have to think about the question first, right? And you have to eliminate the options. Okay, do not directly start solving the question. First try to eliminate the options by knowing the effect of symmetry and so on and so forth, and then start solving the question, right? So first of all, you need to decide what is your target, what is your goal, right? So identification of symmetry is very important, and then which Fourier series coefficient you have to compute, whether it is exponential Fourier series coefficient or trigonometric Fourier series coefficient, AK, BK, CK, okay, or DK, all those things, right? So this is lecture number 33, and in this session I'm just going to talk about removing the DC offset to reveal hidden symmetry. Removing the DC offset, okay, to reveal hidden symmetry. Okay, so whenever xt or anything will be, any signal will be given, okay, any periodic signal will be given, and you have to identify that what kind of symmetry in that. So you will not be able to identify, okay, the moment you see it, okay, because there will not be the magnitude, okay. I will show you, okay. So you have to find out what kind of symmetry it has. Like the moment you see the signal, there will not be apparent symmetry, right? You will not be able to see what kind of symmetry it has. But if you're going to remove the DC offset, okay, if you're going to remove the DC, means you have to subtract DC from the given signal, okay. So you would be able to find out, yeah, there is a even symmetry, there is a odd symmetry, there is a half wave symmetry, and so on and so forth. So adding a DC offset to a periodic signal changes its, you can say, only its DC value, okay, and all other coefficient will be same, okay. Suppose you have got any AC signal, just I'm going to show you. Suppose this is your sinusoidal, right? You can say that xt is nothing but your sinusoidal signal, okay, sine t, okay. So suppose this is your sinusoidal signal which is periodic in nature, right? Okay. Suppose this is 10 and this is minus 10, right? This is minus 10, okay. Okay, and the DC here is 0, okay. DC value for this sinusoidal is going to be 0, average value is 0, right? Because the signal, you can see this x-axis or a time axis which is passing through 0 only, right? Okay, so this point is 0 here, and this sign is, sign is changing from 10 to minus 10, you can say, right? Or let's say 1 to minus 1, okay, 1 to minus 1, right? Because this is the magnitude is amplitude of sine t is 1 to minus 1, right? Now what you can do, you can add DC to this. If you are adding DC to this, okay, like you can say 10, if you are adding 10, right? So what will be there? Your or you can say that you are adding 1 itself. Yeah, you're adding 1, okay, to this AC signal. So this is AC signal, this is DC signal, right? So if you are adding DC signal, okay, so what you're doing, you're adding constant to the function. So if you're adding constant to the function, so your function will shift up, right? Your function is gonna get shifted up. So whenever any waveform will be given, this is called in circuit, if you go, okay, in analog circuit, this is called clamping. Okay, you are clamping up or clamping down, right? If any sinusoidal signal is given and you are adding some DC signal or DC, you can say some constant value to the function, so your function or your signal is, your waveform is going to get shifted up, right, or shifted down depending upon the sign of the DC value, right? Okay, so this is one of the important fact that you have to remember, right? So this is called clamping also. this kind of job is done by clamper, okay, in analog circuit. Okay, so your signal is going to be like this now. So now since you are adding 1, so it becomes 2 and this becomes 0, right? So your signal is going to be like this now, and this is 1, okay, and this is 2 here, then this is 0. So your signal is now moving like this, so you can see, yeah. So this is 2, fine. So hopefully this makes sense, right? So your signal now became like your signal got shifted, so this will be up only, okay. आपको अच्छे से ड्रॉ करना है, ठीक है. So you see now your signal is starting from 1 now, right? It is not starting from 0. So now it has some DC value, and DC value is 1 here, right? Okay. So if you remove this DC value, so again you will get back the sinusoidal, that is AC signal, okay? So you will be able to find the symmetry. Right now you are not able to find the symmetry in this case, okay? You are not able to find the symmetry in this case. You see there is no symmetry at all, okay? Because for odd signal it should be symmetrical about 0 or origin. For even it should be symmetrical about bi-axis, okay? So there is no symmetry right now. No, you can say no apparent symmetry. No apparent symmetry. But if you remove this DC 1, if you subtract, removing means subtracting DC from the AC, right? So you will get some symmetry over there, and that will be odd symmetry. Understood? So let me take one signal here, right? So this is very important to keep in mind, right? So adding a DC offset to a periodic signal, let me write a note. Adding DC offset to a periodic signal. Okay, see, you are dealing with Fourier series, okay? तो आपको हमेशा पीरियोडिक सिग्नल को ही डील करना है, okay? नॉन पीरियोडिक सिग्नल नहीं. Then if the signal is aperiodic or it is not periodic, then we have to go for Fourier transform, okay? So adding a DC offset to a periodic signal, okay, changes is you can say changes its DC value, okay, and all other coefficient is going to be same, and all other coefficients remain same. Okay, all other coefficients are going to be remain same, right? So please do remember this, okay? So if there is, suppose if there is a odd symmetry, okay, so since odd symmetry and half wave symmetry are destroyed by the non-zero DC offset, remember, okay? Suppose there is a odd symmetry or half wave symmetry, and if you are adding DC to the signal, so your symmetry is gonna be destroyed, okay? So it is better to check for such symmetry by removing, after, you can say after removing the DC offset, okay, you can say A naught from the signal, okay? So remember that odd symmetry and half wave symmetry, they get destroyed by DC offset, okay? Now let me take some signal here and show you how to remove that DC, okay? So first of all, signal is given, okay? Let me show you, this is a signal which is given here, okay? And I will ask you what kind of symmetry it has. Number 1. So you can see here, guys, this is 0 here, right? And this signal is, if you compute DC value here, so what is the DC value? How to find DC? DC, you can say A naught, or you can say C naught, or you can say D naught. It's nothing but over a period is 2, so 1 by 2, okay? And what is the area under the 1 period? Area under 1 period means 0 to 2. And what is this? This is nothing but, if you try to find out, okay? So what is the line, straight line equation? Slope is nothing but 1, right? So it is dt. So 1 by 2 and t square, right, by 2 and 0 to 2, right. So 1 by 2 into 4 by 2, which is 1. So your DC value is 1 only here, right. DC value is 1. So what you have to do here is you have to subtract 1 from this, minus, you can say you have to subtract 1. Subtract 1. So if you are going to subtract 1, so this will be, this is 2, so now it will become what? It is going to be coming 1, right. So your signal is going to be from 1 to minus 1, right, and now it is passing through 0. Okay, so let me draw properly. So this line now will be passing, this time axis will be passing through origin like this, and now you can identify that your signal is like this. Okay, now you see here what kind of symmetry it has. This has odd symmetry. Odd symmetry also, okay, it has also half wave symmetry, you can see. Okay. I hope this makes sense, right? So, okay, this has odd symmetry. Okay, odd symmetry is there. So this is 1 for half period. Okay. 1 minute. So let me check out. Yeah. So this does not have half symmetry, right? It has only odd symmetry. Okay, because half symmetry means for half the period there should be suppose amplitude is 1. So for half the for half period, the amplitude must be inverted. Okay, like -1. So this is 2 only, 2. Okay, and this is 4. Okay, and so on. So this is 1 period, right? Okay, so by looking at this signal, okay, this is xt and this is xt. After removing you can say DC value, so you are able to identify there is a odd symmetry. Understand? So I think this is clear. Okay, so in the beginning, whenever you see the signal, now how to decide what DC you have to subtract? So you can find out DC value, right? Okay, you see here. देखो जैसे ही आपको ये सिग्नल दिया हुआ है, right, this waveform is given, right, so you're not able to find out what kind of symmetry it has, right, so there is no apparent symmetry. Okay, but if you remove the DC offset, so you're going to get what? You're going to get the odd symmetry signal. I think this is clear for all, right? So please do remember this point. And if I want to let me take one more signal, right? So suppose we have got a signal, okay, which is nothing but on off signal, right? On off. Yeah. So on off, it is on off, right? You see, on off. Okay, so there is no apparent symmetry. We are not able to identify the symmetry here. This is 0. Okay, now you have to find out what is DC value. DC value, C naught, D naught, all these same. So area under this a signal over 1 period. So what is area here, guys? Area is gonna be 4. So 4 by 2, which is 2. So what you have to do? You have to subtract 2 from there, right? So not 2 here, guys. Sorry. The time period you have to check here is the time period is 4, right? So 1 by 4 into the area is 4. So DC is 1. Okay, always remember the formula 1 by T naught. Okay, 0 से T naught xt dt to find out the average value. So this is the period. Okay, from where the signal gets repeated. Now, and looking at the signal itself, you can tell, yeah, there is a DC value associated with it, and if we subtract DC value, that is nothing but 1. So your signal will become like this. If you subtract 1, so it become 1. This is -1 because 0 minus 1 is nothing but -1. Okay, and now it will be nothing but what? So this is the situation. Okay, I think this is clear. Yeah. So what kind of symmetry it has? It has half wave symmetry. See, for half the period, okay, it is 1, and for half the period it is -1. Okay, so half wave symmetry means for half the period it should be 1, or you can say A, and for half the period it must be -A. Okay, so this is also one important point. So there is a half wave symmetry, guys. Okay. So how to identify the half wave symmetry? आपको समझना है कि for half the period, ठीक है, So the moment you look at the waveform, okay, ये वाला वेवफॉर्म आप देखकर नहीं बता सकते हो क्या सिमेट्री है, नीदर इवन सिमेट्री नॉर ऑड सिमेट्री नॉर हाफ वेव सिमेट्री. लेकिन जैसे ही आप ऑड, मतलब यू कैन से इफ यू आर रिमूविंग, ओके, if you're removing DC value, so you are finding that this has odd symmetry as well, and as well as half wave symmetry, right? Odd plus half wave, odd भी है ना ये, right? At origin it is 0, okay? And there is a half wave, they, you know, about 0 it is symmetrical, understand? So it has odd plus half wave symmetry. Now the moment you are how we are saying that it has odd symmetry, because if you look at this 2 and this is -2, so at 2 this is 1, at -2 it is -1, so there is a symmetric limit, okay, symmetric limit, okay. At symmetric limit the magnitude is same, but they are different from the sign, right? So at 2 here and at -2 both the magnitude is same, right? So we can't say that there is a odd symmetry or something, there is a even symmetry also. So please remember, okay, revise everything that I have told you, okay. I hope this makes sense, okay. So this is one important point that I want to discuss, ki if there is a hidden symmetry, okay, so you have to identify first what kind of symmetry it has. So you have to remove the DC offset, okay. So if such symmetry is present, okay, you can say if such hidden symmetry is present, some of the coefficient will be 0 and you don't have to compute, okay. Like if it has odd symmetry, so you don't have to compute what A naught, you don't have to compute AK, right? You have to just compute BK, okay. And if you compute BK, so you will be able to compute CK, okay. You don't have to separately go through the, okay, because there is a formula called what is the relation between EFS coefficient and TFS coefficient. I have told you that CK is nothing but EFS coefficient AK minus JBK by 2. So if even symmetry is there, so your BK is gonna be 0, right? If even symmetry is there, so BK will be 0, guys. Yeah. So your CK will be what? AK by 2. Only you have to compute AK and A0 separately, okay, and this is C0. And if there is a odd symmetry, so what you have to, you don't have to find A0 and AK, they will be 0, right? So your CK will become what? You plug here B, you know, AK 0, so CK is gonna be minus JBK by 2. So ये प्योरली इमेजनरी होता है, ये प्योरली रियल होता है, ये प्योरली इमेजनरी है, ओके. सो इन दिस मैनर ओरली यू हैव टू रिमेंबर, ठीक है, आपको ओरली याद रखना है, रटना कोई भी पॉइंट नहीं है, ठीक है. यू डोंट हैव टू मग अप एनी पॉइंट at all, right? In fact, I have told you one Argand diagram also, the relation between all the coefficients, right? So please do remember that, okay. So we can then pick the symmetric. Symmetric means zero offset. Something is symmetric, let me tell you, if something is symmetric, it will be having always, remember, zero offset. Symmetric का मतलब होता ही है zero offset, right? It must have zero offset, okay. If pick the symmetry which has zero offset, okay, like odd symmetry, zero offset, even, okay, there will be a zero offset, okay. And in case of, okay, symmetric which has zero offset, okay, most of the time what happens now, odd symmetry as well as your half wave symmetry get affected by these these offset, DC offsets, right? Okay. Okay. So please do remember this. So let me tell you some of the important you can say you can see important note here, right? Or important, you can say important note, okay, to check. And it is also, it will be also important to okay, for and for Fourier series computation, some of the important result, you can say important result to check. And for Fourier series coefficients, suppose we have got e raised to power plus minus j k pi, right? Plus minus j k pi. Okay, so what is the result here, guys? The result is gonna be cos k pi only. What is this? E raised to power plus minus j k pi. Please do remember this. Plus minus j k pi is equal to cos k pi, and cos k pi can be written as minus 1 to the power k. And if k is even, so this is 1. If k is odd, this is minus 1. So if somewhere down the line, if you get this kind of expression, right, e raised to power plus minus j k pi, so that is equal to cos k pi, or directly you can say that that is minus 1 to the power k. And if k equal to even, k even means 2, so minus 1 to the power 2 is 1. ठीक है, तो ये आप यूज कर सकते हो डायरेक्टली, ओके, in Fourier series coefficients, like computation. And if someone is gonna ask you what is sin k pi, sin k pi is becoming 0, okay, sin k pi will be 0. And तीसरा रहेगा sin k pi by 2 and cos k pi by 2. Okay, integer multiple of pi by 2, right? So they are going to be 0 for k even, it is 0 for k odd. So these are the some important you can say checks that you can use to simplify the concept, right? So, and one more thing I want to highlight here is the coefficient of AK, right? Coefficient AK, you can say, or real part of the xk are even symmetric function of k. ठीक है, ये पॉइंट आप याद रखना. जी, ठीक है, फॉर क्विक computation. So coefficient AK is nothing but TFS coefficient, TFS, and real part of XK. XK is nothing but, here I am talking about CK, guys. That is EFS coefficient are even symmetric, okay, as a function of k. And coefficient BK is, or you can say imaginary part of XK are odd symmetric coefficient of, okay. So XK is nothing but CK only, that is EFS coefficient. Because you have to remember CK is nothing but AK minus JBK by 2. So real part is AK, imaginary part is BK. Okay. So let us compute some of the questions, right? So we have to simplify things using signal symmetry. Okay. So suppose we have got impulse train. Impulse train. देखो बहुत सारे क्वेश्चंस आ चुके हैं. If I take some questions here, so GATE, you can say GATE 2020, I think in 2010 ECE branch there was a question. Okay, I can directly take that question if I find. Yeah. Yeah. I will directly take the question, and that was a question, it was asked in GATE 2010, and I think you guys can now answer the question. Okay. So you have to comment about trigonometric Fourier series coefficient. They are nothing but AK and BK. Okay. So let me directly take that question, then we will take the example. Yeah. So this question was asked in GATE 2010. So you can practice all the question in ECE or electrical work. Trigonometric Fourier series for the waveform ft shown below contains. अब देखो यार, if you look at this, so first of all you have to see the, you know, it is ranging from a to minus 2a. This is minus 2a. Certainly there is a DC offset, okay, because they are not symmetric, okay. They are not symmetric, guys, because at t by 4, okay, at t by 4, if you look at t by 4, okay, so there is a DC. Certainly there is a DC, okay. In this signal there is a DC, okay. So if you remove DC, okay, or you can say if you add DC here, so it will be symmetric. So what you have to add, you can add, so there will be a DC. Certainly DC will be there. Understood? So first of all, let us read the options as well, because how I am able to find the DC, that in this given waveform there is a DC component, because this is A and this is minus 2A, right? So they are not symmetric, okay, they are not symmetrical. Okay, if they are not symmetrical, मतलब there is a DC, okay. So यहाँ पर पहला ऑप्शन देखो, only cosine term, zero value, this is not the correct option, right? Zero value for DC component नहीं है, there is a DC, okay. Only cosine term and a positive value for DC. Okay, so what kind of DC value is there, positive or negative? That also you have to identify, right? So yeah, so if you add plus a, then this will become you can say that plus a means this is 2a and this will be a and this is a, right? So what, positive a or minus, what you have to subtract, that is the question. So that also you have to decide. So, and only cosine term a negative value for DC component, only cosine term with negative value of the DC. अब sine term will not be there, right? Sine, because it looks like a, you know, even symmetric, okay. If we remove this DC offset, okay, from here, okay, अगर आप DC offset remove करते हैं, so it can have the okay, even symmetric kind of thing. Understand? Or you can say half wave symmetry as well. Half wave symmetry. Okay, for this period and for this. Okay. So which signal, which option can be correct here? Can somebody tell here? Which option can be correct? Yes. So you can try this question, right? So option A will not be correct. Option D will not be correct. Now there is a fight between B and C. There is a fight between B and C. So which option can be correct? That is my question. Yes. So trigonometric Fourier series was there, okay, and there is a to minus 2a. Your signal is from a to minus 2a. So which answer is going to be correct? That is what you have to check. Yes. So now I have told you these two options you can eliminate, A and D. Think about it. So there is a hidden symmetry, and certainly there will be cosine term present and DC will be present, but that DC will be minus this, okay, minus or plus. That is also one important point. So you can find out, right? You can find out the DC value, and that DC value, you can check out what DC value will be there, right? Understand? So if you look at the DC value, so you have to just find out over one period and check the DC value is positive or negative. Certainly there will be a DC value, okay, that will be negative only, because see, this minus 2a is, this signal is going downward, right? So you are adding more DC, more negative value to this waveform, right? So option C, sir, must be correct, okay. That is also one way of answering the question. Okay, you don't have to compute DC value here. Okay, fine. So let me move ahead, because your signal is going downward, right? So it means you are adding negative to the waveform, more negative to the waveform. Okay, now let us take some examples. So I'm just going to take first example. So impulse train, मैं पहला एग्जांपल लूंगा impulse train का. ठीक है, impulse train मतलब क्या होगा? Impulse train means your impulse is going to look like this. It is periodic after each time period t. This is impulse train. Okay, इसको हम लिखेंगे कैसे? Suppose xt is given, delta t minus, you can say that kt, k equal to minus infinity to infinity. This is impulse train, right? Okay, and there is a time period t. Okay. Now, so if I want to find out, the Fourier series coefficient, okay, so can we find out the Fourier series coefficient? Yes. So we can find out Ck, which is nothing but exponential Fourier series coefficient. So what is the formula for that? Ck formula is 1 by t. You have to, from 0 to t, okay, and for over one period, you can say over one period, right? There is a delta t only, so you can write delta t e raised to power minus jk omega naught t dt. Right? So you know that from the shifting property, okay, you just put 0 here, so it will be nothing but 1 by t for all k. Okay, so area under this will be, using shifting property. Shifting property. It is nothing but 1 by t. Okay, so your Fourier series coefficient is going to be 1 by t for all k, right? So if someone is going to ask you if there is an impulse function, impulse train, you can say, so what is going to be the, okay, understand? Or you can also do like this. एक ये तरीका है. You can also write like this, ck 1 by t, and you can take the symmetric limit minus t by 2 to t by 2 delta of t e raised to power minus j k omega naught t dt. This is also fine. Answer is gonna be 1 by t only for k, because minus t by 2 to t by 2, it is gonna be what? So don't take this one, right? So you can just okay, understood? Better to take that symmetric limit. Okay, that is good. From, you can say this is minus t by 2 से लेके t by 2. You are just, because your delta t exists between these two limits, minus t by 2 delta t, right? ठीक है. So if you indicate this, so you are getting 1 by t for all k. ठीक है. Fine. Let me take one more signal, that is nothing but sawtooth waveform. Example number 2. Sawtooth waveform. Sawtooth signal, you can say. Why we call it sawtooth? Because it looks like a sawtooth, right? Sawtooth will be given, that is nothing but your periodic signal only. So we can find out the Fourier series coefficients. हाँ, जैसे कि ये आ गया, right? Ck you got. Ck is 1 by t for all k. Now what is going to be your, since it is even symmetry, there is a even symmetry, guys. There is a even symmetry, right? Delta t, delta function is a even symmetric, right? So what is ak here? So ck is nothing but ak by 2. So ak is gonna be 2 by t for all k. ठीक है. So you can find out, if you know ck, you can find out ak, bk, everything. If you know ak, bk, you can find out ck, right? So please that okay, those things you have to take care of by yourself, right? Now suppose we have got sawtooth waveform of this kind. What is the you can say, what is the period here? T equal to 1, right? T equal to 1 is the time period, right? Now if you look at this, so time period is 1, so your frequency is gonna be omega naught. Omega naught is going to be 2 pi, okay, by t naught, which is nothing but 2 pi only. Okay, understood. And your signal is periodic, and if I ask you what is the signal expression, right? What is xpt between 0 to 1, right? What is this signal expression? So that is nothing but the slope of this line, that is t. Okay, 1 by 1 times t, okay, and 0 you can say. Don't take 0, this only you have to write, okay, between 0 to 1. And what is the a0? You can find a0. A0 is nothing but DC value. So DC value is gonna be 1 is the time period, and area under this. What is area? Area is gonna be 1 by 2, that is 0.5. So this can be found out by inspection, right? Okay, by inspection you can find out. So also you're not able to identify what kind of symmetry it has. So what you can do, you can just subtract 0.5, okay, from this DC, okay. So if you subtract 0.5 from this, so it becomes 0.5, and this 0 will be shifted to negative 0.5, okay. This signal will be shifted downward, right? So there will be what kind of symmetry? There will be odd symmetry, guys. Okay. If there is a odd symmetry, means what you have to find out. So this signal has XPT has odd hidden symmetry. Okay, so its exponential Fourier series coefficient is going to be imaginary. In this situation, right, you don't have to find AK is going to be 0 for K does not equal to 0. For all K, AK is going to be 0, but for K equal to 0, it is not 0 because there is a DC value. We find out the coefficient, okay, that is nothing but BK. So BK हमें निकालना है for K greater than 0. BK we have to find out for K greater than 0. Because K equal to 0 के लिए तो आपको पता ही है. ठीक है? I hope this makes sense, right? So now what is BK here? So BK is going to be, you just take the time period here, right? So you have to just integrate, right? So from where to where you have to integrate? That is what the question is. So 1 by t minus t by 2 से लेके t by 2, right? 1 by t by 2 xt sin k omega naught t dt. Okay. So what you can do here is, since it has odd symmetric, right? So this is 2, sorry. There will be 2 as well. There will be 2, right? So, and this you can say from 0 to t. We know this formula, right? 2 by t, 0 से t, xt sin. So you can put here, so 2 by 1, 0 to 1, and this is t sin 2 pi k t dt, because omega naught is 2 pi. Now you can integrate this. So this is integration is gonna be, you know, minus cosine 2 pi k t by 2 pi k from 0 to 1. Okay, so this gives you you know, 2 times 2 pi k you can take out. If you plug here, so you know it is nothing but cosine 2 pi k, right? And if you plug this, so plus 1. Okay, minus of minus become plus from the fundamental theorem of calculus first. You simply have to put upper limit minus lower limit. ठीक है? I think something we have done mistake. Yeah, okay, sorry. There is a mistake, okay? I think we have done directly. Just wait, right? There is a UV formula that you have to use. Okay, integration by part formula. Okay, sorry for that. ठीक है? ये यहाँ पर T भी दिया है ना? And there are two signal. Okay, there are two functions. Okay, T and sin 2 pi kt dt, right? Please do remember this. So I just ignored t, right? So आपको पता होना चाहिए. तो ये 2 times of 0 से 1 t times sin 2 pi kt dt. तो आपको समझना है कि ये आपका फर्स्ट है और ये आपका सेकंड है. ठीक है? तो आपको करना पड़ेगा क्या? इंटीग्रेशन, राइट? ओके, इंटीग्रेशन. So you have to use the UV formula. So I think I can introduce UV formula for you. So let me recall. Okay, recall. So suppose I want to differentiate product. So it is nothing but U dash V plus UV dash. Okay. Now what we can do here is we can say that U dash V is nothing but UV dash, okay, minus UV dash, right? You can write like this. You can take this guy that side. Okay. Now you can integrate both sides. So if you are integrating U dash V, okay, so integration of this is nothing but UV only minus UV dash, right? With respect to T, you can say whatever. Okay. So from the product of the derivatives, we are able to get the result here. Now U dash, you can consider U dash, okay? So U dash is this, right? You can take U dash. So T times sine 2 pi kt. Okay, so let me take, so using this, okay, using this formula, so your bk is going to be 2 times 0 say 1. You have to be very careful, right? Okay, while solving it, because I ignored this t, so I was doing something, okay, but as soon as I identify, I change it, okay. So आपको भी यही करना है. So इसीलिए कैलकुलस बहुत इंपॉर्टेंट है. कैलकुलस आना चाहिए सबको. साइन 2 पाई के टी टी. सो आपको करना क्या है, यहाँ पर आइडेंटिफाई करना है u डैश इज नथिंग बट t एंड v इज नथिंग बट साइन 2 पाई के टी, राइट. सो योर vk विल बी 2 टाइम्स ऑफ, ठीक है. बाद में हमें लिमिट रख देना है. uv इज नथिंग बट व्हाट, uv, okay. What is u from here, u dash equal to t. So what is u, what is u? That's what you have to find out. If u dash is t, right, what is u? What is u? So you have to integrate both sides. So it is nothing but t square by 2, right? So t square by 2 times sine 2 pi kt, ठीक है. t square by 2 sine 2 pi kt, right? And then minus, okay, integration, what is that, u is nothing but this. I think we must take yes, fine. So what we can do here is we can take u and we have to decide, okay. Let me first function and the second function. So we can go for islet also. So vk is going to be 2 times of, okay, keep the first function as it is, right. Integrate the second function, that is nothing but minus of cosine 2 pi kt by 2 pi k, and then minus of what, differentiate the first function, and you know there will be I think this is only the case, yeah. So 1 minute, let me directly write, okay. There is a formula of this, okay. So you have to just integrate this, okay. So integration is only the challenge here, right? Sometimes I also find it challenging, but it's fine. So bk is going to be यस, ठीक है, फाइन. सो व्हाट वी कैन डू हियर इज वी कैन से दैट 2 टाइम्स ऑफ आइलेट का फॉर्मूला लगाते हैं. ठीक है, देखो इंटीग्रेशन बाय पार्ट्स वी हैव टू यूज, राइट. ठीक है, तो इंटीग्रेशन बाय पार्ट्स, लेट मी राइट द फॉर्मूला क्लियरली. I wasted a lot of time, right? इंटीग्रेशन बाय पार्ट्स, ये फॉर्मूला भी है. ठीक है, यू गाइस कैन चेक आउट दिस फॉर्मूला. एक फॉर्मूला ये भी होता है, यू वी डी एक्स सपोज यू हैव टू डू, राइट. देन व्हाट यू कैन राइट इज फर्स्ट फंक्शन वी डी एक्स माइनस सेकेंड फंक्शन. तो पहले फंक्शन का डिफ्रेंसिएशन करना है एंड सेकेंड फंक्शन को इंटीग्रेट करना है एंड देन ओवरऑल इंटीग्रेट करना है, राइट. चलो ये फॉर्मूला हम लगा देते हैं. ठीक है, अब तो क्लियर है. वी के यू 2 टाइम्स ऑफ फर्स्ट फंक्शन. अब देखो कैसे हम चूज करते हैं फर्स्ट फंक्शन, आइलेट यूज करते हैं. तो ओके, so algebraic we can take first function, then we can take second function as trigonometric, right. So first function is nothing but t, second function का integration, so that is gonna be minus cosine 2 pi k t upon 2 pi k. this is done minus first function का differentiation is 1, second function का integration, right. सेकंड फंक्शन का इंटीग्रेशन क्या है, माइनस कोसाइन 2 पाई के टी बाई 2 पाई के एंड दिस इज नथिंग बट डी टी ओनली, राइट. लिमिट वी कैन पुट लेटर. सो फर्स्ट ऑफ ऑल यू कैन सॉल्व इट, राइट. सो इसको आप देखेंगे यहाँ पर वी के 2 टाइम्स, इट इज बिकमिंग लेंथी, राइट. सो आई विल फाइंड सम इजी अप्रोच. You can say cos 2 pi kt cos 2 pi kt by 2 pi. ठीक है, and this becomes plus. अब इंटीग्रेट करना है किसको, कोसाइन को इंटीग्रेट करना, राइट. सो कोसाइन को इंटीग्रेट करेंगे तो क्या हो जाएगा, साइन आ जाएगा, राइट. सो दैट इज नथिंग बट साइन 2 पाई के टी बाई 2 पाई होल स्क्वायर, राइट. और ये 0 to 1. फैंटास्टिक. ओके, so bk is going to be 2 times. Okay, now what you can do here is you just put 1 to all, right. So 2 pi k is, this is 0, certainly this will be 0 if you put 1, right. And this is nothing but cosine 2 pi k by 2 pi k, right. If you plug 1 and this is 0, now if you plug 0, so this is nothing but 0 only. So this is 0 and this becomes also 0. ठीक है, so इसका आंसर कितना आ रहा है देखो, there will be a minus sign, okay, because minus sign is there. So bk is going to be, now you know that cos 2 pi k is nothing but 1 only because 2 is even. So this is minus 1 by pi k, right. So your bk is nothing but minus 1 by pi k. ठीक है, minus 1 by pi k, minus 1 by pi k for k does not equal to 0. Please do remember this. ठीक है, so मैंने क्या किया, स्ट्रगल कहाँ पर था, स्ट्रगल वॉज इन इंटीग्रेशन बाय पार्ट्स. Okay, so I also got sometimes because if you are not in practice, okay, so you might get lost into mathematics. ठीक है, तो आपको थोड़ा सा यहाँ पर ध्यान देना है. आई थिंक आप मुझसे ज़्यादा अच्छे होंगे कैलकुलेशन में, ठीक है. So sometimes I get lost into math also. So इसको इंटीग्रेट करना है, सिंपल है, इसमें कुछ भी नहीं था. I took, ओके, तो आपका रिजल्ट ये आ गया. अब बीके आ गया तो हाउ टू फाइंड सीके, राइट? सो यू नो सीके दैट इज EFS, यू नो EFS कोएफिशिएंट. अब आपको पता है कि देयर इज अ हिडन ऑड सिमेट्री, राइट? सो यू नो AK इज गोना बी 0 ओनली. सो इफ AK इज 0 मतलब CK कितना हो जाएगा? -j BK/2. सो CK इज गोइंग टू बी, BK कितना आया यहाँ से? ये हो जाएगा यू नो J/2πk, J/2πk, right? Yeah. और K does not equal to 0, right? Yeah. तो बहुत सारे लोग तो अभी तक इतना कंफ्यूजन में रहे होंगे कि हाउ डू वी फाइंड आउट द कोएफिशिएंट फॉर ऑल फॉर्म्स ऑफ ट्रिग्नोमेट्रिक फोरियर, ऑल काइंड ऑफ फोरियर सीरीज फॉर्म्स, राइट? सो दिस इज हाउ वी फाइंड आउट. अगर आपको बीके पता चलता है तो आप निकाल सकते हैं, ठीक है? और somebody will find C naught, so that is 0.5 only. Yeah? और आप देखोगे, नोटिस करोगे, दिस इज प्योरली इमेजिनरी because the signal is odd, right? Given waveform is odd, right? And आप समझ सकते हो, ठीक है? तो Fourier series को exponential Fourier series coefficient is gonna be odd. So I think this is clear for all, right? So this is how you have. Now let us take one more signal that is called triangular, triangular pulse train. Triangular pulse train. अब देखो triangular, you can remember also the results, but I don't recommend to remember the results, right? So suppose we have got the triangular pulse train. ये triangular pulse train है, right? Now are you able to identify the what kind of you can say this signal has what kind of symmetry this signal has? Yes, you can say that there is a even symmetric, okay, it is even symmetric signal, right? And you can compute A naught as well, right? So find A naught. So in this case BK is gonna be 0, right? So you can find A naught, which will be 0.5. AK you can compute, BK is gonna be 0. Why? Because there is a even symmetry. Okay, there is a even symmetry. Now the time period you can decide. The time period is going to be t equal to 2. So your omega naught is pi. Okay, time period is this. So omega naught is pi, and between 0 to 1. If you look at, so what I told you, you have to always take the symmetric limit, right? So at 1, at -1, okay, it is even because amplitude is same here, right? So you can say xpt is one, t, ये line का equation for t lying between 0 to 1. बस आपको इंडिकेट कर देना है यहाँ पर. इंडिकेट कैसे करेंगे? You have to just find AK. AK is nothing but 4 by the time period, that is 2, and 0 to 2. I mean 0 to 2, but now you have to go from what? 0 to 1 only, right? So your formula should be like this: 4 by t, 0 से लेके t/2 xt cosine k omega naught t dt. So 4 by t, 4 by 2, 0 to 1 t cosine k omega naught is pi, right? So you can just write pi here, k pi t dt. अब क्या करना है? Again, what do you have to do? You have to just integration by part, right? So this is 2 times, पहले को as it is रखना है, कोसाइन का करना है, तो it is nothing but sin k pi t by k pi माइनस इंटीग्रेशन ऑफ कोसाइन करना है, और तो ये हो जाएगा sin k pi t by k pi dt। फिर से 0 to 1 बाद में रखना है, राइट? सो इट विल बी नथिंग बट 2 times ऑफ this term will be always 0 because sine 2 pi sine k pi t, whether you put k or k equal to 1 or 0, k pi, इसको इंटीग्रेट करेंगे तो कितना आ जाएगा? कोसाइन, सो माइनस ऑफ माइनस दैट इज नथिंग बट प्लस कोसाइन के पाई टी बाई के पाई होल स्क्वायर, नाउ 0 to 1। तो आपको पता है कि ये वाला टर्म तो वेदर यू पुट 1 इन प्लेस ऑफ टी और 0 इट विल बी 0 ओनली, तो 2 टाइम्स ये तो 0 ही रहेगा बाय डिफॉल्ट, राइट? ठीक है, it is 0 and this is going to be your cos k pi, cos k pi यहाँ पर रहेगा cos k pi by k pi whole square। Now if you plug 0 here, so it is 0 and it will be surviving minus 1 by k pi whole square। ठीक है, so I think this is clear for you, right? so इसको और सिंप्लीफाई कर लेते हैं, so we can write this as 2 times of cosine k pi minus 1 upon k pi k square pi square, right? ठीक है, now you know that cos k pi is -1 for k odd, right? So you can put here, so this is -1 here, so it is -4 by k square pi square for k odd, right? ये आपका क्या आ गया सर? ak आ गया, only for ak, right? For even harmonics it is gonna be 0, right? That is also you have to understand, ठीक है? इवन हार्मोनिक्स में क्या रहेगा? ये 0 रहेगा, ठीक है? तो आंसर ये ऑड हार्मोनिक्स के लिए सर्वाइव कर रहा है। Okay, so you have to note that for even k, right, the ak is going to be 0, okay? For even k, ak is going to be 0. So what is the meaning of that? It implies there is a hidden half wave symmetry. It implies there is hidden half wave symmetry, ठीक है? Hidden है, okay? Why hidden? Because the DC value is not 0. Because a naught is not 0. Now you found out ak, now how can you find ck, right? So if you have got ak is nothing but -4 pi square k square for k odd, ठीक है? So what is ck? ck is nothing but EFS coefficient, इसको 2 से डिवाइड कर दो, that is ak by 2, so ये आ जाएगा -2 k square pi square for k odd। I think this is clear for all, right? So in the question they will give you options, right? So you can verify all these things, right? So you can also eliminate the options and you don't have to go through this many steps, right? Okay, in the examination, right? That is what I just want to convey, right? आपको options दिए रहेंगे 4 options, तो आपको verify करना है, ठीक है? Okay, suppose we take sawtooth signal and there is a half wave symmetry, right? So then again you have to find ak, you have to find bk, right? And then what you have to do? You have to find ठीक है, ठीक है। तो हम एक क्वेश्चन और लेते हैं, हाफ वेव सिमेट्रिक सॉटूथ सिग्नल। सो बी कंफर्टेबल विथ कैलकुलस, राइट, ठीक है। हाफ वेव सिमेट्रिक सॉटूथ सिग्नल। अब हाफ वेव सिमेट्रिक सॉटूथ सिग्नल है तो आपको समझ जाना है कि आ, जो आपका सी के आएगा दैट विल बी कॉम्प्लेक्स, राइट, ठीक है। तो हाँ, ओके, लेट मी टेक दैट सिग्नल दैट इज पीरियोडिक ओनली, ये। So the moment you see in your exam this kind of a signal, right? So it looks like a sawtooth, but it is half wave, right? For half the period, this is the one. For half next half the this is -1, right? So that's what you have to understand. Yeah. So you can find out the time period. So time period is nothing but 2 omega naught is pi, 2 pi by 2, that is pi. And you can say that your xpt, the periodic signal, is t, okay, between 0 से लेके 1, ठीक है। So what you can comment here is there is a half wave symmetry, so your dc value is 0 here. If you compute dc value, right, so you are going to get 0. So we have to compute ak and bk. Now how to find ak? ak is nothing but 4 by t, 0 से लेके t by 2 xt cosine k omega naught t dt. Now ak, what is 4 by t? T is nothing but 2, 0 से लेके, now your xt we are considering till 0 to 1, right, half the period, right? So 0 to 1, understand? So you don't have to integrate this and this, you have to only integrate this, okay, because that is what the case is, okay. So please do remember. So 0 to 1, ये t cosine k omega, omega is nothing but pi, guys, so just replace this guy with pi t dt. अब ये बार बार आपको आ रहा है सिग्नल, राइट, सो यू शुड रिमेंबर आल्सो, राइट, के पाई टी। अब इसको फिर से इसका रिजल्ट क्या मैंने निकाला था एक बार रिकॉल करिए, राइट, सो दैट इज नथिंग बट -4 के स्क्वायर पाई स्क्वायर -4 के स्क्वायर पाई स्क्वायर, राइट, फॉर के ऑड। ये रिजल्ट आप याद रखिए जब भी ऐसा सिचुएशन आएगा तो, ठीक है। और जब हम बीके की बात करते हैं तो बीके में भी 4 by 2, 0 to 1 टी साइन के पाई टी डी टी, ठीक है। तो इसके लिए भी आप याद रख सकते हैं, ओके, और else you can just integrate it, right? So you will get here 2 by k pi for k odd. Half wave symmetry मतलब odd harmonics will exist only, ठीक है। Now AK BK you have found out, then you can find out CK. CK is nothing but what? AK 1 by 2, AK minus JBK 1 by 2. AK is nothing but -4 by k square pi square minus j 2j upon k pi, okay, for k odd. So you can cancel 2, so it is nothing but -2k square pi square minus j by k pi, right, for k odd. Fine, so this is what the situation is, this is how we compute the okay, and आपको समझना स्मार्ट बनना है कि कैसे हम, हाँ, थोड़ा सा इंडिकेशन बाय पार्ट इज देयर, राइट, सो यू कैन डू इट, राइट, नो प्रॉब्लम, बट डोंट वरी इन द एग्जाम नो लेंथी क्वेश्चन कम्स, ठीक है। आप एक स्टेप में आंसर निकाल पा रहे हैं, बट आपको समझना है कि कौन सा फॉर्मूला कब यूज करना है, राइट, कौन सा एनालिसिस इक्वेशन कब यूज करना है, सिंथेसिस इक्वेशन के लिए. Now, so that's what I would say. So you guys can try other questions, okay, from the Ambader. ठीक है. Now we will talk about one of the very important concept that is called Parseval relations. Parseval's relation. आपको Parseval relations बार बार आएगा in frequency domain. Parseval relation and the power in periodic signal. See, if the signal is periodic, right? You know how to find the power directly in the time domain itself, right? Okay. Over the time period, you have to find the energy and then divide by the time period. Okay, that you know. Okay. How to find the power, right? So if the signal is periodic signal is periodic. So power is gonna be average power, going to be over one period, 1 by t over t xp squared t dt, right? Over one period only you have to just integrate, that's it, right? So the given periodic signal, it is very easy, you know, to evaluate the signal power in time domain, right? Very easy. To compute power in time domain, or you can see evaluate. बहुत ही easy है, direct, ठीक है? Then why this Parseval relation? Since the Fourier series describes the periodic signal, okay, as a sum of sinusoids at different frequency, right? So the signal power also equals to what? The sum of the power in each sinusoids. Signal power will be equal to what? That is one of the important fact you have to remember, right? ठीक है. तो आपका xt इक्वल टू क्या होता है? xt इक्वल टू we say that है ना, ये xt इक्वल टू a नॉट प्लस a1 साइन a1 कोसाइन ओमेगा नॉट t प्लस a2 cosine 2 omega naught t plus and so on. So average power क्या हो जाएगा सर? Average power is gonna be the sum of the individual powers, right? The जो भी powers harmonics में present है, right? Okay. So please do remember this fact. ये वाला fact तो हम लोग network में ही पढ़ते हैं, right? Since the Fourier series describes the periodic signal as a sum of sinusoids at different frequencies. Frequency must be different, okay? I have told you also in one of the session. So आपको ये समझना पड़ेगा, ठीक है? Its signal power also equals to the sum of the power in each sinusoids. इसमें जो पावर है, इसमें कितनी पावर a1 बाई a1 स्क्वायर बाई रूट टू a1 स्क्वायर बाई 2, इसमें कितना पावर है a t स्क्वायर बाई 2, राइट? इसमें कितना पावर है a नॉट स्क्वायर ओनली. ये सब आर्थोगोनल भी होते हैं, ये इसके आर्थोगोनल है, ये इसके आर्थोगोनल है, राइट? सो दैट यू हैव टू अंडरस्टैंड, राइट? अगर आर्थोगोनल नहीं है देन देयर इज अ प्रॉब्लम, राइट? सो यू हैव टू, आई हैव एक्सप्लेन्ड, ठीक है? होपफुली दिस मेक्स सेंस, राइट? So yes, so suppose you have got complex exponentials, right? I mean, exponential Fourier series coefficient is given and you have to find the power to determine power, okay? You can use the Parseval relation, right? The Parseval relation says that, what Parseval relation says that the average power is equal to 1 by t over t dx pt dt is equal to, okay, this is the power in time domain, and the Parseval relation is going to connect, okay, the power relation in time domain as well as the frequency domain. So if this coefficient is given, so your power is gonna be, you know, ck a whole square, where k is running from minus infinity to infinity. So you have to just take the mod of ck and square it and add all to get the power. Okay, that's what you have to do. You can also write this ck, I mean, you can also write this k as minus infinity to infinity. This is nothing but ck times ck star, ck times ck star. Okay, you can write this like this. Okay, fine. In terms of trigonometric Fourier series, suppose trigonometric Fourier series is given, TFS coefficients are given, and you have to find the Parseval relation, right? So Parseval relation P average in time domain, that, you know, you have to just find the energy over a xpt. I think I miss square here, right? So you have to square it. Squaring is very important, right? That becomes the you know, you have to just take a square plus, okay. Now summations will be k from k equal to 1 to infinity 1 by 2, right? 1 by 2 ak square plus bk square. That's easy. Okay, that's very simple. Okay, ये बहुत ही सिंपल, कहाँ से आता है आपको पता चल जाएगा, राइट? देखो TFS क्या होता है? What is TFS? TFS is nothing but a naught plus summation k equal to 1 to infinity ak cosine q omega naught t plus bk sine q omega naught t. Now you have to find the power here. The average power is gonna be equal to a naught square plus summation k equal to 1 to infinity. What is power of this? ak square by 2 plus bk square by 2. यही है पार्शियल रिलेशन. तो आपको फॉर्मूला बता दिया जाता है, आपको ये नहीं बताया जाता ये आता कहाँ से फॉर्मूला है. तो प्लीज डू रिमेंबर, एंड आपको याद रखना है कि ये सारे के सारे ऑर्थोगोनल होते हैं. दिस इज ऑर्थोगोनल टू दिस, दिस इज ऑर्थोगोनल टू दिस, दैट्स व्हाई वी आर एबल टू राइट दिस all the okay. And in terms of if you want to compute in terms of polar form, तो पोलर फॉर्म में भी आप कर सकते हैं. पोलर फॉर्म का क्या रहेगा? P average is going to be, you know, d naught square plus equal to 1 to infinity 1 by 2 dk square, right? ये सारे रिलेशन आप याद रखिए. बस याद क्या रखना है, अगर आपको बहुत ही सिंपल है, राइट? आई नीड नॉट टू डिस्क्राइब दिस. ओके, ठीक है. देखो अगर आपको ये पता है, क्या पता है, जैसे मान लो XPT EFS पता है, क्या होता है EFS? PK raised to power JK omega naught T, K running from minus infinity to infinity. Now you have to find power. To find power you have to square it. Okay, so summation will be there. Take the mod of this, so it will be 1 and ck का square. Okay, so this is the relation. So I'm just going to show you, right, the total power that you can find out, right? Okay, so it is far easier to obtain total power using periodic signal. लेकिन finding the power in, or you can say up to a given number of harmonics requires the harmonic coefficients, right? So suppose they have given some harmonics and you have to find the power till the required harmonics, right? Suppose you can say n harmonics are given, nth harmonics are given, right? So that k equal to 1 to n, the formula will be changing. Okay, the formula will be changing and formula will be like this. ये फॉर्मूला आप याद रखना, ठीक है? देखो, तो अभी ये किसके लिए है सर? ये पोलर के लिए है, पोलर where c naught is d naught. I mean, just you can change, right? I don't want to, this is polar, right? D naught you can take, right? And ये किसके लिए है? TFS के लिए है, और ये किसके लिए है? Exponential. Now the harmonics n infinity नहीं है, तो ये फॉर्मूला यूज करना है. सो पार्शियल रिलेशन का मेनली पार्शियल थ्योरम जो होता है, राइट? सो अब जैसे जैसे हार्मोनिक्स इंक्रीज होंगे, योर पावर विल अप्रोच टू द ट्रू सिग्नल पावर, यू कैन से, राइट? Because this is going to be a positive quantities, okay, and it is always less than the total power signal. ये पॉइंट भी आप याद रखिए. So notation wise इसमें क्या है? This is xk means ck only, ck, right? That is, so whatever notation I have told you can use it, right? पार्शियल रिलेशन का यूज बस यही है कि इफ यू नो दी हार्मोनिक्स कोफिशिएंट्स देन यू कैन यूज दी पार्शियल रिलेशन, अदरवाइज यू कांट यूज इट. ओके, एंड इट इज वेरी इजी टू फाइंड आउट दी पावर फ्रॉम दी टाइम डोमेन सिग्नल. तो अगर आपको वेव फॉर्म पता है तो आप डायरेक्टली फाइंड करिए. अगर मान लो उसका कोफिशिएंट दिया है देन यू कैन फाइंड दैट. तो मैं तो ये सजेस्ट करूंगा, वेव फॉर्म दिया तो आप डायरेक्टली पावर फाइंड करिए, ठीक है? डोंट वेस्ट योर टाइम. लेकिन मान लो अगर कोएफिशिएंट दिया है तब आप पार्शियल रिलेशन का यूज करिए, ठीक है? दैट इज माय सजेशन. ओके, फाइन. सो विल मीट इन द नेक्स्ट सेशन गाइस. अब नेक्स्ट सेशन में हमारा क्या आने वाला है? आई विल टॉक अबाउट स्पेक्ट्रम ऑफ द पीरियोडिक सिग्नल्स. Spectrum of periodic signal, right? Like we'll talk about magnitude spectrum, magnitude and phase spectrum. क्योंकि कभी कभी क्या होता है कि they will give you magnitude spectrum and the phase spectrum and they will ask you to find out Fourier series, right? एंड बहुत सारी चीजें हैं, तो क्वेश्चन आजकल कुछ भी आ सकता है, राइट? तो स्पेक्ट्रम ऑफ द पीरियोडिक सिग्नल वी हैव टू डिस्कस, एंड देन वी विल टॉक अबाउट signal symmetry from its spectra. Suppose any spectrum is given, so how can you identify the signal symmetry, right? Signal symmetry, this is first, then second is signal symmetry. ये सब क्वेश्चन गेट में आ चुके हैं. Signal symmetry from its Fourier series spectra. Okay, so many students, like many of us, we are not able to identify, मतलब इसीलिए Fourier series का क्या है, बहुत ही difficult हो जाता है. तो we will discuss that also. और उसके बाद हम लोग we'll solve questions, right? And then we'll go to properties of Fourier series. तीसरा में properties of Fourier series. So please do remember that. ये सारे टॉपिक्स हम नेक्स्ट सेशन में कवर करने वाले हैं, ठीक है? After that, I think everything will be summed up. Okay, so we will talk about Dirichlet conditions, right? And then yeah, the chapter is gonna be over. So now you guys can try. Okay, you guys can try questions from Ambader. Ambarder, and you can try question from PYQ, right? Or I will share some question in the group, right? So we'll meet in the next session, guys. Thank you. Yeah. Or please do practice calculus. ओके यार, थोड़ा फोकस लाना पड़ेगा. जैसे अगर मान लो आप इंटीग्रेशन कर रहे हैं, जैसे मैं कर रहा था, एंड आई वाज स्ट्रगलिंग इन कैलकुलेशन. सो आपको ये नहीं सोचना है कि धीरज सर को वो चीज़ नहीं आती है, राइट? आई एम स्ट्रगलिंग जस्ट लाइक यू कैन से आई एम आल्सो काइंड ऑफ स्टूडेंट, यू कैन फील इट, राइट? सो you might be in the same condition, right? So I'm teaching you live, right? Okay, so I'm thinking about it. So we have to, now there is a difficulty in इंटीग्रेशन बाय पार्ट. नाउ आई हैव टू टेक केयर. अच्छा, ये पॉइंट में हमें दिक्कत आ रही थी, अब इसको हम अच्छे से करेंगे. तो वी हैव टू फोकस. फोकस इज वेरी इंपॉर्टेंट. ठीक है, थैंक यू. वी विल मीट